Hello everyone, welcome you all in class 11 Geography. This is chapter number 11 Water in the Atmosphere of Physical Fundamental book. This is 11th chapter and this is the module number 1 of this chapter. So basically we will discuss about the water in the atmosphere. Means what are the different form of the water in atmosphere. How the water exists in atmosphere and what are the different work of the atmosphere and how it change and transform in different part. So let's start the topic. Water is present in the atmosphere in three more forms, as you know, and you read this thing from the junior classes that there is a presence of water in three forms: gas, liquid and solid. In gaseous form it is formed in vapor, in liquid form it is formed in water, and in solid form it is formed in ice. So in this way there are three forms of the water present in the atmosphere. The moisture in the atmosphere is derived from the water bodies through evaporation. Means from water bodies, the evaporation basically derived from evaporation from the water bodies, and from the plants this is the process of the transpiration. So basically we can say कि water का steam बनना water bodies से, that is known as the evaporation, और plant से through the plant, this is called transpiration. So the process of evaporation and transpiration, condensation and precipitation. So in this way there is a exchange of water between the atmosphere and oceans and continent. Form of evaporation, transpiration, condensation and precipitation. So there are four forms. From there is an interchange of water from water body to atmosphere and from atmosphere to water body. The first term of water, that is the humidity. What the mean of humidity? Water vapor present in the air is known as the humidity. Whatever be the water vapor present, as you know, the structure, or we can say the component of the atmosphere, there are three component or constituent material of atmosphere. This is the water vapor, dust particle and gases. So water vapor in air is called as a humidity. Second, absolute humidity. Second term, this is the absolute humidity. So the actual amount of water vapor present in the atmosphere is known as the absolute humidity. Whatever be the water vapor present in the atmosphere, this is called as humidity present in air, and in the present, or we can say the actual amount of water vapor present in the atmosphere is called as absolute humidity. So it is the weight of water vapor per unit volume of area and it expressed in term of gram per cubic meter. यानी कि per unit area में, per unit volume of air में, the presence of the humidity is called as absolute humidity. And whatever be the moisture or whatever be the vapor present in air, this is called humidity. So the basic difference between humidity and absolute humidity regarding for a particular area basically. Now the next term is the relative humidity. We just discussed the absolute humidity. Now the second term is the relative humidity. So the percentage of moisture present in the atmosphere compared to its full capacity at given temperature is known as the relative humidity. Whatever be the temperature, so on the particular temperature, whatever be the fullest capacity of air to holding the moisture is called as relative humidity. यानी कि एक पर्टिकुलर टेम्परेचर पर एयर जितना वेपर और जितना मॉइस्चर होल्ड कर सकती है उसे हम कहते हैं रिलेटिव ह्यूमिडिटी. सो एब्सोल्यूट ह्यूमिडिटी इज कंसर्निंग टू पर्टिकुलर एरिया और रिलेटिव ह्यूमिडिटी concerning to the particular temperature in the air. If we talk about the relative humidity, so it is greater over the ocean and least over the continent. So this relative humidity, this is greater over the ocean and least over the continents. Now next term is the saturation. So the air containing moisture to its full capacity at a given temperature, it's said to be a saturated or a saturation. It means on a particular temperature, whatever the fullest capacity of a air to holding the vapor, it's called the saturation. Means on that temperature air can't hold excess vapor. So the point which it hold the vapor, this called as saturation point of the air. Next term, that is the dew point. So dew point, the temperature at which saturation occurs in a given sample of air, it's known as the dew point. Means जिस sample of air में, जिस part of air में पर्टिकुलर गिवन टेम्परेचर पर सैचुरेशन अकर होता है, इट मीन्स कि उस पर्टिकुलर एयर पार्सल में और ज़्यादा मॉइस्चर को होल्ड करने की, और ज़्यादा वेपर को होल्ड करने की कैपेसिटी नहीं होती. सो दिस पॉइंट इज नोन एज ड्यू पॉइंट. Now we will see the two important point, that is the evaporation and condensation. So through the evaporation water become from liquid form to gaseous form, and by condensation the water become from gaseous form to liquid form. So basically this is the transformation of the water from gaseous to liquid form or from liquid to gaseous form. Evaporation is a process by which water is transformed from liquid to gas state. Heat is the main cause for the evaporation. As you know, the evaporation is a simple process. So who is responsible for the evaporation? Heat is responsible for the evaporation, and by this process the water transformed into the gaseous state, यानी कि वाटर का लिक्विड स्टेट से गैस स्टेट में कन्वर्ट होना, ट्रांसफॉर्म होना, दिस इज कॉल्ड इवेपोरेशन एंड द बेसिक कॉज बिहाइंड हीट. The temperature at which the water starts evaporating, it referred to as the latent heat of the vaporization. यानी कि वेपर होने की, वाटर के वेपर बनने की, वेपराइजेशन होने की जो रेट है, सो जिस रेट पर, जिस टेम्परेचर पर वाटर इवेपोरेट होना स्टार्ट करता है, इवेपोरेशन की प्रोसेस स्टार्ट होती है, उस हीट को हम बोलते हैं लेटेंट हीट ऑफ द वेपराइजेशन. एज वी कैन सी द टेम्परेचर इंक्रीजेज, वाटर अब्जॉर्बिंग एंड रिटेंशन कैपेसिटी ऑफ द गिवन पार्सल ऑफ द एयर ऑल्सो इंक्रीजेज. यानी जैसे जैसे हम टेम्परेचर इंक्रीज करेंगे एयर का, वैसे वैसे उसके अंदर मॉइस्चर को होल्ड करने की कैपेसिटी भी क्या हो जाएगी, increase हो जाएगी. Once again I am repeating, as we increase the temperature, the air parcel, the capability of the air parcel to holding the vapor is also increases. So the moisture contained is low, air has potential of absorbing and retaining moisture. Movement of air replaces the saturated layer with the unsaturated layer. Suppose एक जगह पर लेयर एयर है और वो वहाँ की जो मॉइस्चर होल्डिंग कैपेसिटी है वो सैचुरेटेड पॉइंट पर आ गई है, लेकिन अब जब एयर का मूवमेंट होगा एक प्लेस से दूसरे प्लेस पर, सो लेयर्स में डिफरेंस आएगा और टेम्परेचर में भी चेंज आएगा. एंड एज यू नो व्हेन द टेम्परेचर इज चेंजेस, सो द एयर कैपेसिटी ऑफ द होल्डिंग टू vapor is also increases, also changes. So movement of air is also responsible for the increase of evaporation rate. It means the greater the movement of air, the greater is the evaporation. यानी जितना ज़्यादा एयर का मूवमेंट होगा उतना ही टेम्परेचर चेंजेस होंगे, क्योंकि विंड टेम्परेचर चेंज करने के लिए रिस्पॉन्सिबल है एक जगह से दूसरी जगह पर, और जैसे जैसे टेम्परेचर चेंज होंगे इवेपोरेशन की रेट भी इंक्रीज होती जाएगी. Next term, that is the condensation. So the transformation of water vapor into the water is called as condensation. Means the water convert from gas state to liquid state. Condensation is caused by the loss of heat. As we saw this thing, evaporation caused by the increase of heat, and condensation is caused by the loss of heat. When the temperature is decreases, so there is a condensation process held. When moist air is cooled, it may reach at level when its कैपेसिटी टू होल्ड वाटर वेपर सीज, यानी कि जब मॉइस्ट एयर का टेम्परेचर स्लो या डिक्रीज होता है और उस लेवल तक पहुंच जाता है जब वाटर को होल्ड करने की और कैपेसिटी उसके अंदर सीज हो जाती है. सो द एक्सेस वाटर वेपर कंडेंसेस इनटू लिक्विड फॉर्म. तो उस कंडीशन में जो एक्सेस वाटर वेपर होता है वो धीरे धीरे कंडेंस यानी पास पास आने लगती हैं, जिसकी ड्रॉपलेट डिफरेंट ड्रॉपलेट्स दे बिकम टू कन्वर्स and they convert into water drops. Different water droplets make a water drop, and in this way the vapor convert into a water. It is the directly condensation into the excess water vapor condense into the liquid form. If the directly condense into the solid form, suppose जो वेपर है अगर वो लिक्विड फॉर्म में कन्वर्ट ना होकर डायरेक्टली सॉलिड फॉर्म में कन्वर्ट होगी, मीन्स इट मीन्स इन द फॉर्म ऑफ हेल्स, सो the process is called as sublimation. So we can say the formation of the hails is called as sublimation. In free air, condensation result from cooling around very small particle term as hygroscopic condensation nuclei, यानी कि जिन स्मॉल पार्टिकल्स के चारों तरफ वाटर ड्रॉपलेट्स accumulate होना स्टार्ट करती हैं, तो इन dust particles को we can say these hygroscopic condensation nuclei, and without the hygroscopic condensation nuclei condensation can't be held. So there are different kind of hygroscopic nuclei like particle of dust, smoke, salt from the ocean, and particularly good nuclei because they absorb water. Condensation therefore depend upon the amount of cooling and relative humidity. So basically condensation is depend on cooling of air and relative humidity of the air. Condensation is influenced by the volume of air. If the volume of air is high, so condensation can't take place. Temperature, if the temperature is high, it can't take place. Pressure also, if pressure is high, condensation can be placed. And the humidity, if humidity is high, the rate of condensation is high, or if the humidity is low, the rate of condensation is also low. So in this way we can say there are different terms when the condensation take place. So the first term, when the temperature of the air is reduced to dew point, अगर एयर का टेम्परेचर ड्यू पॉइंट तक रिड्यूस होता है, सो विद इट्स वॉल्यूम रिमेनिंग कांस्टेंट, लेकिन जो वॉल्यूम है एयर का वो कांस्टेंट है, लेकिन टेम्परेचर अगर डिक्रीज हो जाए ड्यू पॉइंट से, सो इन दिस वे और इन दिस सर्कमस्टांसेस कंडेंसेशन टेक प्लेस. देन सेकेंड, व्हेन बोथ द वॉल्यूम एंड द टेम्परेचर आर रिड्यूसेस, अगर वॉल्यूम भी रिड्यूस हो जाए एयर का और टेम्परेचर भी रिड्यूस हो जाए, सो इट मीन्स वॉल्यूम कम हो गया और टेम्परेचर, सो इन बोथ कंडीशन कंडेंसेशन कैन टेक प्लेस. When moisture is added to the air, suppose there is a rainfall, and in this way there is a addition of the moisture in the air through evaporation के भी through. So however the most favorable condition for the condensation is the decrease in the air temperature. So in this way we can say the most favorable condition, यानी कंडेंसेशन की प्रोसेस के लिए सबसे इम्पॉर्टेंट टर्म है द डिक्रीज इन द टेम्परेचर, और इवेपोरेशन के लिए सबसे इम्पॉर्टेंट टर्म है इंक्रीज इन टेम्परेचर. व्हेन दीज टू प्रोसेस हेल्ड, द इवेपोरेशन एज वेल एज द कंडेंसेशन प्रोसेस इज हेल्ड. आफ्टर कंडेंसेशन द वाटर वेपर और द मॉइस्चर इन द एटमॉस्फेयर टेक वन of the following term. So there are different forms of the water vapor in the atmosphere: dew, frost, fog, clouds. Forms of condensation can be classified on the basis of temperature and location. Condensation take place when the dew point is lower than the freezing point as well as higher than the freezing point. Because अगर freezing point से ज़्यादा होगा तो in that condition there is a freezing form, condensation can't be held. और अगर freezing point से बहुत ज़्यादा कम होगा तो it means temperature high होगा, तो उस form में भी condensation can't be take place. There are some forms, or we can say the different forms of the water इन एटमॉस्फेयर और कंडेंसेशन फॉर्म्स, यानी कंडेंसेशन के डिफरेंट फॉर्म्स हैं, मॉइस्चर के डिफरेंट फॉर्म्स हैं एटमॉस्फेयर में, किन किन फॉर्म में वो मॉइस्चर जो है एटमॉस्फेयर में एग्जिस्ट करता है. फर्स्ट, this is the dew. So when the moisture is deposited in the form of water droplets, as I told you, the small droplets, and togetherly they called as drop on cooler surface of the solid object, यानी किसी भी solid object की surface पर जब छोटी छोटी droplets दिखाई देती हैं, such as stones, grass blades and plant leaves, this is known as dew. So this is known as dew, and in Hindi we can say this thing as a os. The ideal condition for the formation of dew, clean sky. These are the ideal condition when there is a clear sky, calm air, high relative humidity and cold and long nights. So basically dew form in the winter nights. For the formation of dew, it is necessary that the dew point is above the freezing point, because if the dew point is to freezing point, the water convert into the solid form and the basic form of the dew can't be happen. Next one, this is the frost. Frost form on cold surface when the condensation take place below freezing point, means below the 0 degree, so the water convert into the solid state. The dew point is at or below the freezing point, so the excess moisture is deposited in the form of minute ice crystal. So it means minute ice crystal means the water in the form of solid state instead of water droplets. So basically we can say if the water deposited in the water droplets, this is called dew, or if the water deposited in the ice crystal, this is called frost. So the basic difference of the dew and frost, temperature. If the temperature above the freezing point, this is dew, and if the temperature below the freezing point, this is the frost. Ideal condition of the formation of white frost are the same as the formation of dew, means there should be a clear sky, calm air, high relative humidity, cold and long nights. The air temperature must be at the below the freezing point, because when the temperature is below the freezing point, only in that condition there is a formation of ice crystal, otherwise there is formation of water droplets, and that is the form of dew. Next is fog and mist. So when the temperature of an air mass containing a large quantity of water vapor falls of a sudden, condensation takes place within itself on fine dust particle. So the fog is a cloud with its base at a very near to the ground. Because of the fog and mist, the visibility become poor to zero, means it can be opaque. And in urban and industrial centers, smoke provide plenty of nuclei which help the formation of fog and mist. So such a condition when fog is mixed with smoke, this is called as smoke. यानी जब fog और smoke दोनों mix होते हैं तो उस condition को हम क्या बोलते हैं? Smog बोलते हैं. The only difference between the mist and fog, this is the mist contain more moisture than the fog. यानी कि basically fog ground से थोड़ा, क्योंकि अगर surface पर touch होगा, so this is the form of dew. क्रिस्टल फॉर्म में होगा, दिस इज द फॉर्म ऑफ फ्रॉस्ट. सो दिस बेसिकली दिस इज द इन गैसियस फॉर्म, और ग्राउंड सरफेस से थोड़ा सा ऊपर, सो दिस इज द फॉर्म ऑफ फॉग. फॉग और मिस्ट का बेसिक डिफरेंस यही है कि मिस्ट बेसिकली माउंटेनियस एरियाज में ज़्यादा होती है क्योंकि वहाँ पर मॉइस्चर ज़्यादा होता है, और अर्बन एरियाज़ में या रूरल एरियाज़ में यानी कि सेटलमेंट एरियाज़ में फॉग का फॉर्मेशन होता है क्योंकि उसमें मॉइस्चर थोड़ा सा कम होता है. द बेसिक डिफरेंस बिटवीन फॉग एंड मॉइस्ट ओनली द मॉइस्चर. Mist are frequent or mountain as the rising warm air up to the slope meets a cold surface. Fog are drier than the mist and they are prevalent where warm current of air come in contact with the cold current. So basically mist वहाँ form होते हैं mountainous region में, और fog कहाँ form होते हैं जहाँ cold और warm currents, ocean currents basically मिलती हैं, या settlements area में भी. Fog are मिनी क्लाउड इन विच कंडेंसेशन टेक प्लेस अराउंड न्यूक्लिया, यानी न्यूक्लिया जो हाइग्रोस्कोपिक न्यूक्लिया की हम बात कर रहे थे, सो डस्ट पार्टिकल, सॉल्ट पार्टिकल्स, दीज वर्क एज अ हाइग्रोस्कोपिक न्यूक्लिया। सो जहाँ भी न्यूक्लिया की प्रेजेंस होगी वहाँ फॉग के क्लाउड्स इनके चारों तरफ फॉर्मेशन हो जाएंगे। सो न्यूक्लिया प्रोवाइडेड बाय द डस्ट, स्मोक एंड द सॉल्ट पार्टिकल। Rest of topic we will discuss in the next module, module number 2. Thank you.